In this Gem Cut Studio or GCS tutorial, I'm going to take parts of two existing diagrams and merge them together into a newish design for a very special piece of rough that I have. After a very long search, I finally located a special piece of gem rough for a special design that BOPIE has in mind. I don't want to give a lot of details away at this project just yet, as the project may not work out. But I have a large piece of internally flawless quartz, and BOPIE has a piece of jewelry in mind that she will design. She needs a large heart gem as the centerpiece for her design. I'll post a link to cutting the rough in the comments, or maybe here in the video, depending on when I finish cutting the gemstone. So my idea is to have the top part of the stone or crown to be cut using step cuts, as this tends to make gemstones look more of a kind of refined, kind of like how step cut emerald designs make emeralds look refined or classy, as opposed to the brilliance look of, say, a standard round brilliant design. So for the top half of the heart design or the crown, I searched for a step cut design and found one I like. It's called Sweetheart 3, and the design was created by Horton and Norman Steele in 1993. And this is what it looks like. Again, I like the look of the upper half of this gem fastening diagram. The lower half or pavilion is not what I'm looking for in this cut that I have in mind. Just the crown or upper part. For the bottom half or pavilion part of my heart design, I found a pavilion design that I like. It's part of a design by Robert Strickland called Apex Checkerboard Heart. Robert says he got the design from an idea by Sid Ward. The pavilion is already set for RI of 1.540, which you may recognize that as of quartz. Here is what Apex Checkerboard Heart looks like. I have cut checkerboard designs before, and they are fun to cut and look great, but that's not what I'm looking for this specific piece of rough that I have. I do, however, like the way the lower half or pavilion of Robert's gem fastening design looks, and I think that will work perfectly for the design I have in mind. So I'll go with these two designs and cobble them together, like the Johnny Cash song, One Piece at a Time. I'll put a link here to Johnny Cash's song, and I recommend you listen to this classic recording while you watch the rest of this video, as I feel like I'm following in Johnny Cash's footsteps in putting this design together from parts taken one at a time. And like the Johnny Cash, where he needed the help of an adapter kit to put all his parts together, I also needed an adapter kit. My adapter kit is called Gem Cut Studio. So there's an old saying that I learned from my Army days that basically goes, the enemy of a good plan is the dream of a perfect plan. And it's by Clausewitz. Well, the Army made me study Clausewitz a bit, but honestly, when I was reading his book, there were paragraphs written by Carl Vaughan that were more than a page long, so I didn't get a whole lot out of those studies. But this one short quote of his makes sense. I don't want to spend months designing the perfect heart-shaped design. I just want something good that does what I need. So keep that in mind when you add your comments about what I should have tweaked a bit differently, done slightly differently. Remember, I'm not trying to be a gem cut designer, and I believe I can save a whole lot of time by taking parts from other existing designs to get the design that I'm looking for. First step is to go to facetdiagrams.org and open and download both of these .asc files into my GCS library on my computer. Then I simply open the files, save them again as a .gcs file, which is what GCS uses. I've covered how to do this in previous tutorials, so I won't repeat the process here. Here's a link to the GCS playlist that I created where I'll put all my GCS tutorials. Just look at the previous tutorials and to see any steps that I don't cover here. Now that we've converted these two designs to GCS files, just for fun, let's see how they currently perform. That'll give us a baseline for how our final heart-shaped design should look. Something to shoot for as far as brightness, windowing, and head shadowing of my final design. The Apex design is already set for quartz with an RI of 1.54, so when I select tilt performance, I can see that at face up or 0 degrees, the tilt gets about 70% brightness, about 30% of head shadow, and just a bit of windowing. Not bad. I explained how to use tilt performance in previous tutorial, so again, take a look if you want a more detailed explanation. The Sweetheart 3 design is optimized for an RI of 1.76, which is corundum, ruby, and sapphire. Using tilt performance again, I see that face up, I get about 70% brightness, 20% window, and 10% head shadow from this design. Now, if I change the RI to quartz, I'll probably run into problems, but let's see. As explained in a previous tutorial, you go to Render, change the material to quartz, which changes the RI to 1.54, accept the changes, and run tilt performance again. Brightness dropped to about 55%, window increased to about 35%, and head shadow increased to about 10%. Not as good as before. But let's move on and see what our final cobbled together design looks like for quartz. I'm going to be happy with anything in the 70% range for brightness. I'll start with the apex design. First, I'll need more girdle to play with, so I will go to resize girdle and change it to 6% of stone width, just so I have something to cut on. With GCS, I can always readjust the girdle later after I finish the design. Now I'll save this file and call it part working copy so I don't mess up the original designs. So there are 19 facets going around the pavilion of Apex. All I am using the Sweetheart 3 design for is to see how they made the steps. So to make the steps in a crown, I just need to cut the same indexes in the crown as were cut in the pavilion for the Apex design. Sweetheart 3 steps in the crown were cut at angles of 50 degrees, 37 degrees, and 22 degrees, and then of course the table. But this was for a design in a different RI than quartz, which is what I'm going to cut my stone in. So let me go out and take a peek at a couple of regular rectangle designs for quartz and see what angles other designers have used to cut step cuts in the crown of gems for quartz. I'll spare you the details of the search, but here's what I saw in the steps. Generally, they have 5 to 10 degrees between steps, and for quartz, they range between 47 and 38-ish degrees. Again, referring back to long-winded Clausewitz, good enough is good enough. I believe I'll try the step angles of 42, 37, and 32 degrees, and then cut the table, about 5 degrees between each angle on the crown. And that's really all I needed the Sweetheart 3 design for, so I'm done with that design. So now back to the heart working copy file. Now I just need to match the indexes cut in the pavilion on the crown with an angle of 42 degrees, then repeat it for 37 degrees and repeat it again for 32 degrees. I'll eyeball the distance between steps for what looks good to me, and then I'll add a table and voila, I'll be done. I'm going to use the same indexes as P1 through P6, but at an angle of 42 degrees to make the C1 through C6 instructions for the crown. So click on the indexes for P1, select Edit Tier, then select Cancel. That releases P1 from being edited, but it also locks in the indexes that P1 already loaded. So now click Crown and put in 42 degrees as the angle. I used the slider to eyeball the step cut, so I get about the size I want. Click Cut, and the first set of crown instructions are done. Now for P2. Select the P2 line. Again, select Edit Tier, select Cancel. Ensure the angle's at 42 degrees. Select Crown. And use the jump feature until I meet the first crown tier that I previously cut. Press Cut. Done. Now for P3. Or C3. Select the P3 line, again, Edit Tier, Cancel, Crown, ensure the angles are 42 degrees. Jump will not meet up with the crown tier that I want, and I need Reg to explain why not. I'm not exactly sure, I'm not an expert on GCS, but anyway, this is not a problem. So instead of using the jump feature, just use the slide bar, and when you get close, use the fine adjustment of the slide bar to have the facets meet up. Press Cut, done. Now for C4, select the P4 line, edit tier, cancel, crown, 42-degree angle, select jump until I meet the first crown tier, press cut, and done. C5, select the P5 line, edit tier, cancel, crown, 42 degrees, select jump, and when I meet the crown tier that I previously cut, press cut, and done. For the C6 line, select the P6 line, go through the same thing, edit tier, cancel, select crown, 42-degree angle, select jump, and when I meet the other crown tier, press cut, and done. Now I will move all the 42-degree tiers up so that they are properly called C1 through C6. And then I will delete the old tiers or rows on the crown because we won't be using them in this design. To move tiers up, just highlight the tier, select move up, and to delete the old tiers in GCS, just select those tiers and select delete tier. Now we can repeat the process for step cuts with the angle of 37 degrees. The first 37-degree angle step is tier C7. Select the C1 line because it uses the same indexes. Again, select edit tier, then cancel. Ensure the angle is 37 degrees and use the slider to eyeball a step cut the right width that you want. Again, you can select fine to make small moves in the slider and get the cut just where you want it. Press cut and done. Tier C8 has the same indexes as C2, so follow the same process. Select C2, edit tier, cancel, 37 degrees, and jump to the meet point, cut, and done. Tier C9 has the same indexes as C3, so follow the same process. Again, the jump feature doesn't align perfectly, so I had to use the slider bar and the fine button to fine tune it so it meets at the meet point. Tier C10 has the same indexes as C4, so follow the same process. Tier C11 has the same indexes as C5, so again, simply follow the same process. Tier C12, it has the same indexes as C6, so again, follow the same processes. And okay, this row of step cuts is complete. Now we just need one more row at 32 degrees following the same exact process. The first 32-degree step angle is tier C13, but I select C1 line because C1 through 6 use the same indexes that I need for C13 through C18. Follow the same process of selecting edit tier, then cancel, ensure the angle is 32 degrees, and use the slider to eyeball a step cut that gives you the right width that you want. You can use the fine adjuster to make small adjustments to get the cut just where you want it. Press cut and done. For tier C14 through C18, they have the same indexes as C2 through C6, so follow the same processes and jump to meet points using the 32-degree angle for each tier. Now we just need to cut the table. Set the angle to 0 and just use the slider to place the table where you want it. Now let's see how our new design performs. And to do this, again, we'll select tilt performance. Well, when we use tilt performance at the 42, 37, 32 angles, we get a brightness of about 70%. It's a little less. Window about 10%, head shadow about 20%. So our new design has about the same performance, at least in brightness, as the old designs that it's based on. But let's go ahead and take a peek at the manual optimizer feature and see if we can tweak this design a little bit with our manual optimizer. So the design in the manual optimizer below our design, and our design is always at the center in the manual optimizer, it shows a slight increase in performance with brightness hitting a solid 70%, window 10%, head shadows 20%. This performance increase is done by lowering the crown angle slightly to around 39, 34, and 29.35. We don't lose much crown. You won't even notice it by looking at the stone. It still has a nice crown, at least to my eye. And when you look at the instructions, the crown to width ratio is 0.121, which is fine. So I think I'll go with this tweak to the crown angles as recommended by the manual optimizer of GCS. The CW ratio and all the ratios can be seen by going to print and looking at the PDF instructions of our new design. Now let's use the cutting assistant feature of GCS to see how a piece of rough would be transformed into our new cobbled together gem faceting design. Go to tools and then cutting assistant, and I'll go tier by tier through the cutting instructions instead of the option of facet by facet. And we'll see how this design will be cut by following the cutting instructions. I'm happy with this new design. So the dilemma now is this a new design that I can claim credit for? I'm not trying to become a gem faceting designer, and I don't feel that I designed this cut, others did. But for sure, this gem faceting diagram does need a new name. I can't very well call it the Sweetheart 3 Apex Checkerboard Heart Cobbled Together Modified Gem Faceting Diagram, because that doesn't very well describe this new design. So I'm going to call this design a stolen heart. How's that? And in the notes, I will give 100% of full credit to the original designers of these two designs that I borrowed heavily from to create a stolen heart. I'm sure some of you won't be satisfied, but I think Johnny Cash would give me a thumbs up. So please let me know your thoughts in the comment. Here's the gem faceting information for a stolen heart. And a stolen heart name, well, that fits perfectly into the design that I plan to cut with my legendary stone rough using this design. So, and I'll put that link here or in the description when I cut this design. It just depends on which video goes out first, this tutorial or the cutting of the stone. And here are the cutting instructions for a stolen heart. In this tutorial, I've shown you how you can take parts from other existing designs to create a new design. I've taken concepts from several existing gem cutting designs, borrowed one piece at a time from the designs, used GCS to cobble together everything into a new design, and also to tweak the performance to about the best level I can get. And the result was the creation of a stolen heart. It's a design which I will use to cut a special piece of rough that I have. So I hope you learned something from this tutorial. I know I learned a lot on this project and in my continuing journey to learn all about GCS. I hope you're enjoying the journey as much as I am, and please let me know in the comments what you think and what other aspects of GCS you'd like me to fumble through and try to learn and teach. And as always, and most importantly, happy faceting, everyone.